I'm Dr. T and welcome to my office. Today I'd like to talk about moons, specifically our moon. So in general, a moon is going to be a relatively large natural satellite. Tiny grains of sand, etc. don't usually get considered to be moons, although there's not really a particularly great definition for the difference between small thing orbiting a planet and an actual moon. Now, when it comes to moons, ours is, relatively speaking, very large, around 1/6 the size of Earth, at least in terms of mass. Because of this, there's actually some rather interesting effects. They're more dramatic on Earth than they would be on other planets, which either have smaller moons or the planet is much bigger, and therefore, relative to the size of the planet, the moon is relatively smaller for those other planets. Now, because the moon is relatively large and orbits Earth, it has a couple of noticeable features. One of the noticeable features, kind of one of the most noticeable features for our moon, is that while it does not emit light itself, it does reflect light. And as we look up, if the moon is visible, then the side of the moon that is being illuminated by the sun will be bright to us because it's reflecting light. Now, of course, how much of that side we're able to see depends on where in the orbit or in the moon's orbit the moon is. And thus, at times, the moon is opposite us and the sun, so sun, earth, moon, and we can see the day side of the moon. Great. At other times, it's at a right angle to us, and we can see part of the moon. So part of it is brightly illuminated, and the rest of it is dark. You can't really see the dark spot, so it kind of looks like it's not there, even though it's definitely still there. It's just not illuminated. And of course, for part of its orbit, it is between us and the sun, and therefore you're seeing the night side only, and well, the night side isn't all that dramatic. Yay. Now, the moon's orbit is somewhat offset to that of the Earth's, so most of the time, the Earth, the moon, and the sun don't line up. However, occasionally they do, and you can get a couple of scenarios when this happens. So if a new moon, that's when the moon is between the Earth and the sun, does line up directly with the sun, then the moon's shadow will be cast on the Earth, and that is an eclipse. Now, because the moon is significantly smaller than the Earth, the shadow cast by the moon on the Earth doesn't envelop the whole Earth. So instead, depending on where you are on the Earth when the moon lines up with the sun, then some people will see the moon completely block the sun, at which point you can see the sun's corona, which is really cool to do. A total eclipse is absolutely fascinating. Alternatively, if you're in a slightly, not quite lined right up, you'll see a partial eclipse, so it looks like the moon is going over the sun. Pro tip, don't look straight at the sun when it's doing this. Only when it's in the full eclipse is it safe to look at without having something over your eyes specifically designed to look at the sun with. Because once again, it's bright! And then for most of the Earth, it looks like nothing has happened because the shadow of the moon has not gone over where they're looking at. Now, of course, the reverse also does happen. The Earth will cast shadow on the moon or for a lunar eclipse. These are going to be a little bit different in feel. So obviously it depends on where the shadow hits, etc. The Earth is large enough that depending on alignments, the Earth's shadow can completely envelop the moon. Now, because the Earth has an atmosphere, the light will be bent around through the atmosphere. And different colors will bend at different amounts, and as such, the red light is better able to make it to the moon. So in that case, the moon will get much dimmer because most of the light is being stopped, and it will get much redder. This is sometimes referred to as a blood moon, although that's not a technical definition. One of the other features that the moon does, other than involving light, is with its gravity. So of course the moon is quite large. It's not a planet, but it is nice and round because it's got lots of gravity, about 1/6 that of Earth's. So because of this, the moon is able to pull on Earth. In reality, the Earth and moon orbit each other. The point that they circle is actually within the Earth. That's why we're considered an Earth, the Earth with its moon and not a binary planet. So as the two orbit, we have a rather interesting feature on Earth. We have water. And so the water that's on the moon side will actually be pulled a bit towards the moon. And interestingly enough, because the Earth is being pulled towards the moon as well, because remember the two are actually orbiting each other, the water opposite the moon will be a little bit pulled back from the Earth. So it's kind of being, the water, the Earth, and like, kind of scenario. This leads to our tides. The water closest to and opposite of the moon is going to be a little bit higher up on the Earth than it is on the opposite sides. So the higher up water, that's going to be the high tide, and the lower is going to be the low tide. This creates a bulge that the Earth rotates around. Now, if you've got a small body of water, the difference isn't going to be much, but if you get a big body of water, you can actually have some fairly dramatic tides. Now, the moon isn't the only thing with gravity, and it isn't the only thing involved here. The sun is a lot bigger than the moon, but it's also a lot further away, so it has less of an impact on tides than the moon does, but it does definitely have an impact on tides. So as such, depending on your tide, certain times of the year, specifically when you've got things like new moons, you're going to have much more dramatic tides. But once the moon is, kind of at a right angle to the Earth, so you're seeing, half the moon being illuminated, those tend to be a much more diminished tide. So with that said, have a wonderful day.